Okay, year 13. Here is example 2, and it reads that we have to find the value of this definite integral, definite because of the limits here, 4 and 9, of the square root of x dx. Now, really, what this is asking you to do, this integral, when it says find the value of, it's really asking you to find the area under the curve of y equals the square root of x between x equals 4 and x equals 9. Okay, so let's look at what this curve looks like, and I've done that on the next page, so I'm going to have to zoom out and go to the next page, and then hopefully this will be quite clear. There we are. Now let's zoom in, and there we go. That's too much. There we go. Okay, so let's have a look at this. Well, here I've done a quick sketch of what the square root graph of x looks like there, and I've done the same there. And I haven't put them on the same diagram because I don't want to overload it with detail. Here you've got, I've drawn where x equals 4, I've drawn a vertical line up there. So what we're really doing is we're finding the area underneath the graph from 0 to 4, and we're finding the area underneath the graph from 0 to 9. Okay, now imagine we combine these two graphs together like that, and you can see that the area that we're being asked to find between x equals 4 and x equals 9, this one here, it's really that area here, that one, being taken away from this much bigger area there, because there's the 4 area there in this little corner here, and if we take that smaller area away from that larger area, we're left with this area here. Okay, and I've said all that there, but you'll notice that it's this big area minus that area there. That's why that minus sign creeps in. All right, now this involves a tiny little bit of algebra before we can do some get some actual values for this this area. So this is the way it goes. Okay, it would look like this. So you're integrating this square root of x, okay, between the limits of 4 and 9. First thing is really to make that x to the power of a half, because when we integrate this, we increase the power by 1, divide by the new power. Now, you will notice that I have integrated, but I've kept this vertical line showing me that I've still got to apply the limits to my answer. Well, x to the power of a half plus 1 is really x to the power of 3 over 2. Okay, so that is the new power underneath 3 over 2. The limits are still written in. Okay, and what I've gone and done now is I have rearranged it slightly, because x to the power of 3 over 2 is the same as this here, but when we're adding the powers like that, what we're really doing is saying it's x to the power of 1 multiplied by x to the power of a half, because in that case we would add the powers just as we did there. But this, I've done it as a top-heavy fraction there and there, because this 2 on the bottom finds its way onto the top in the numerator there. Okay, if you don't understand how that happens, I can easily show you in class when we get back, but it's really a basic division of fractions. Okay, so that 2 ends up on the top, so you end up with something that looks like the following. Okay, and it's going to be 2x, there it is, 2x multiplied by, well, if it's x to the power of a half, then it's the square root of x, and it's all over 3. Notice we still have not yet applied the limits, and this is now what we do. when we've simplified the algebra as much as we can after the integration. So what we do now is we put in the limits of this 9 into there, and then the 4. We subtract the limits when it's 4. What does that look like? Well, it looks like this. Let's put that up like that, okay? So I'm now putting 9 in place of x there, and I'm now putting 9 in place of x there. So I'm working all of that out, and this is really, the value of that is really the area from 0 to 9. Remember the big area? That's what that really stands for. And we're taking away this one when we put this limit of 4 into this thing here. Okay, 2 times 4 times the square root of 4. All of that, of course, is really the area from 0 to 4. So we're taking this smaller area away from the bigger area there, and that will give us the area that's left over from 4 to 9. Okay, well, let's work all that out, and it's very straightforward. Square root of 9 is 3. That 3 will cancel with this 3 here. 2 9s are 18. There it is. Minus, well, square root of 4 is 2. 2 4s are 2 2s are 4 times 4 is 16. So it's 16 over 3. And if we take this is here 5 and 1/3. If we take 5 and 1/3 away from 18, we end up at 12 and 2/3 units squared. Now this is not an approximation. That's the beauty of integration, of definite integration, is that it gives us an absolutely precise answer to the area underneath curves. Okay, well that's it basically, guys. If you want to, I will upload this video so you can look at it yourselves at your leisure. But I will put up exercises for you to try for yourself. All right. Okay. Thank you very much.